If you're an early stage Web3 founder, apply to our award-winning accelerator program, Basecamp, at outlierventures.io/Basecamp. We write your first $50,000 check and give you access to 200 mentors, including many of the leading Web3 founders, and a network of 1,000 of the world's leading investors and exchanges. We've helped over 30 startups from 15 countries from all around the world raise $130 million in growth funding and can help you fast-track product market fit and, where relevant, the launch of your token economy. Today, I'm really happy to welcome Mark S. Miller, Chief Scientist at Agoric. Welcome, Mark.
Hello.
So, as I said, you're Chief Scientist at Agoric. Agoric, very succinctly described, allows for secure smart contracts. We're going to unpack that a little bit later. Effectively, you empower developers to execute transactions, establish new markets. Agoric is obviously Greek for markets, and craft novel exchanges, all importantly without centralized control. As a disclaimer, Outlier was an early investor in Agoric, although I have never had the pleasure of meeting Mark. So I'm glad I have the excuse of the podcast to get you on. You're, as I said, currently Chief Scientist at Agoric and a member of ECMA Script, the JavaScript committee, which I believe you've been doing for some time now. Brendan Eich, creator of JavaScript, CEO of Brave Software, also an early investment of Outliers, describes it as this: the relationship with you is this. I've worked with Mark on JavaScript on the committee for over 10 years, and he's done more than anyone to bring real-world security to the JS community. So good praise indeed. So the reasons why I have you on the show, as if I should have to explain it, to be honest with you. If anybody doesn't know of you, I'd be amazed. But you would be regarded as one of the founding fathers of the internet. So we were discussing off air, describing you as a founder of Web3 now. You actually predate even being a founder of Web 1. So founder of the internet, Web 1, 2, 3, maybe even 4, who knows? So you've been a researcher at Xerox PARC, Google, Xanadu. Your research is focused on language design for secure open systems. Most prominent contributions have been in the area of programming language design, most notably the E language, which demonstrated language-based secure distributed computing. Your work's inspired several adaptations to other programming paradigms, and you've been instrumental on the ECMA Script Standards Committee, as I mentioned earlier, and as was referenced by Brendan Eich. And there's so many things that we could talk about. I would love to talk about episodes and episodes full of conversation, I'm sure, and insights and wisdom. However, we've only got 45 minutes. And so the thing that we're going to try to focus on anyway, hopefully with a few detours, is smart contracts, their history, present problems, and how Agoric is solving for them. So I'm going to try to just blitz describe your background. Again, it's just no way I'm gonna always do it a disservice. Perhaps you can stop me and help me pause on the bits that are most relevant to smart contracts and the kind of main topic of discussion. But as I said, you're a researcher at Xerox PARC, 1985 to 1988. I think I was about 4 then, so just out of diapers. You were architect at Xanadu Operating Company, 1989, the first hypertext project founded in 1960 by Ted Nelson. Loads of interesting innovations that came out of that, very specific to World Wide Web, Web 1. The first version of Agorics, which you founded in 1994, with some of the same founders that you've carried into Agoric, or Agoric 2.0, as we might want to call it. We're again talking off air. This has been a decade-long journey. That's why the company now shares the same name as then. Started with the same mission. You got a bit sidetracked for a couple of decades, but I think the world's probably grateful for it, looking at what you managed to achieve there. And so it'd be good to understand the beginning of the first Agoric. As I said, Agora means Greek marketplace, or it means marketplace in Greek, and this context of market-based distributed secure computing. So let's start there, because that already probably needs some unpacking. Why did you found it? What was the mission and purpose behind it? And I guess some of those seeds that have led to Agoric 2.0 we see today.
Okay, so recapping it chronologically, let's say quickly, it actually all started for me in 1983. I was enthusiastic about, I was a young software engineer, enthusiastic about software engineering, had the object-oriented paradigm was very, very new back then. I was very, very excited about object programming. And then completely separately, kind of as a hobby, I was very interested in economics, very taken especially by the writings of the economist Friedrich Hayek. And I mentioned to a friend of mine, Eric Drexler, I was talking about why I was so excited about object-oriented programming. I explained to him about encapsulation, about how an object is a security boundary that encapsulates an internal state in response to abstract requests from other objects, but it's only the code of that object can manipulate its internal state. And Eric said, oh, that's like Hayek's explanation of the utility of property rights. And that to me was the grand aha moment that changed the rest of my life, is that for all of the normal economic explanations that we might be more used to about property rights, aligning incentives and all that, Hayek's core explanation was in terms of information and complexity and plan interference and plan coordination, is that you've got this, the way I would put it now, the way I do put it now, is that we can understand both large-scale software systems and human society as a whole as consisting largely of networks of entities making requests of other entities. It's the architecture of the request making, the architecture in which the requests are made and responded to, and how that composes together in large networks that creates the emergent properties of the system as a whole. And what software engineering emphasizes and what Hayek was emphasizing very much with the same concepts but completely disjoint terminology is that you've got this large-scale system that's trying to take a lot of knowledge into account in order to create some big, rich, emergent effects. But the total amount of knowledge and the total complexity of the effects brought about is larger than any one entity participating in the network. In software engineering, we have to take a large program and break it down into small objects, where each object only knows a little bit. In human society, there's Hayek's great phrase about how the benefit of civilization is it's able to bring about effects that take more knowledge into account than the knowledge that can fit into any one human head. So what Hayek emphasized is that there's this tremendous number of plans that separate people are separately formulating. There's all of these resources that those plans are in terms of, that the plans would make use of as the plans unfold into the world. And without some special arrangement, you would have this tremendous unsolvable combinatorial explosion of plan interference problems, as one person's plans would make you presume that they can make use of resources that another person also has conflicting plans to make use of, and these plans would tend to conflict. Hayek stated that the central problem of economics is how is it that separately formulated plans formulated mostly in ignorance of each other, tend to mesh well. They certainly sometimes interfere, but altogether they tend to mesh well, which is why civilization works, why society is able to create so much wealth so quickly, why we are all able to benefit from participating in voluntary cooperative relationships with each other. And the central insight is that by dividing up the resources into these separately owned parcels, where each planning agent knows that there's a range of resources that they can formulate plans in terms of, where those plans can unfold free of arbitrary interference from the plans of other agents, because those resources are owned by the planning entity. But that was a complexity payoff, not an incentive payoff. It was specifically a complexity payoff for dividing up the resources of society into these separately owned parcels that could be subject to manipulation by separately formulated plans. And then the message passing level of objects, where objects make abstract requests of each other, where the abstraction of the requests is separated from the details of how the requests are carried out, once again is reflected in the marketplace and Hayek's explanation of prices as a coordinating signal that when a customer makes a request to the business, it's making a request for product. It's not making requests for a product that's manufactured in some detailed manner. It's up to the business how to make use of the business's resources to manufacture the product. So that was very much where I started in 1983. And by 1988, Eric Brexer and I had published a set of papers, the Agoric Open Systems papers. So both of my companies, Agorics and now Agoric, are named after those Agoric Open Systems papers. And that's when we talk about creating the Agoric paradigm of secure, distributed, market-based computation. I'm referring very much to the paradigm that started off in those papers. And there was one major insight that we did not have yet at the time we wrote the papers that we then got from Nick Szabo. When we later made contact with Nick Szabo, and Nick Szabo came up with the idea of smart contracting, that was sort of the important next insight. In those papers, we were really focused on markets as a coordinating mechanism inside computation, where you've got an operating system scheduler that's reformulated as an auction process, auctioning off the next CPU time slice for the highest bidder, where we've got memory space allocated in what we call the rental auction. So the idea was that within computation, we wanted to make use of prices as a coordinating mechanism so that each individual component would be guided by the price information that they have, the current price of memory and processor time and other resources, to make trade-offs as if guided by an invisible hand to serve the overall efficiency of the system. We wanted to replace the central planning approach to allocation of computational resources to processor scheduling, memory, and we saw distributed computing coming. And we knew that at the scale of distributed computing, that kind of central planning notion would break down. We're looking to markets internal to computation. What we got from Nick Szabo is that a lot of the mechanisms that we were creating, which we now call smart contracting mechanisms, they were mechanisms whose purpose was internal to the computational system. Nick Szabo's work points out that you can use automated computational processes embodying contracts, much like the contracts we had been writing, but where the things of value being manipulated are of value that's directly apparent to human beings, that they can be trading stocks and making loans and doing auctions where there are human participants. So raise it up to the point where it's still you're benefiting from the unambiguity, the uncorruptibility of representing the contracts as code that executes, where you can read the code, you can analyze the code, you can try out the code in experimental test harnesses under emergency conditions. You can get all the benefits from the automated execution of the contracts, or the contracts themselves can be serving much of the role that we currently take human contracts to serve, manipulating resources, assets of direct significance to humans.
Wow. I mean, that was, I think for most listeners who have first understood or come across smart contracts in the context of Ethereum, it just goes to show the level of thought that's been happening and progress being made to get to that point. And I mean, it's amazing that you're still innovating in the context of smart contracts. So we're going to get into that in a little second. So as I said, between 1996, Agorics, Agoric 1.0 and Agoric now, which was founded in 2018, as I said, you had a bit of a detour. I'm sure you didn't stop thinking about this stuff, but you worked at HP Labs as visiting scientist 2003 to 2007. You're a research scientist at Google 7 to 18, so a long time there at Google. Again, working on things like JavaScript. So back to,
Let me interrupt you there and say that one of the things I'm very, very proud of is that although it's very non-obvious looking at concretely at what I did, that entire time I stayed on mission. The entire time I was working towards these goals in different ways that I'm now bringing together and making pay off. So at Agorics, the company in the 90s, we did our first industrial strength distributed secure object capability language called Joule, primarily designed by Dean Triple, who's now CEO of Agoric, and was one of the co-founders of Agorics. Also, Dean Triple was a co-architect with me at Xanadu. So we did a first production distributed secure object capability language. I then went to Electric Communities, where we did a successor of that called E, the secure distributed language you referred to. From late 90s until when I joined Google in 2007, we had a open source community. We grew an open source community around E, and even though E was a general purpose secure distributed language, the focal use case, the particular thing that our community was all focused on as the motivating use for doing e-programming was smart contracting. And we wanted to make smart contracting something that was understandable and reliable, and something where programmers could form intuitions about the security implications of the code using an extension of the existing intuitions that programmers have from software engineering around practices like encapsulation and abstraction, is to tighten those up into where those are now security mechanisms, and the security intuitions is an extension of object-oriented compositional intuitions. So we did that. We did that beautifully well. The E language was a great research testbed in how to write smart contracts in an understandable and reliable manner, and in a highly compositional manner, with great compositional properties. Then when I joined Google in 2007, Doug Crockford, who is at Yahoo, convinced me that the JavaScript language, which was in a much cruder form than current JavaScript, it was ECMAScript 3 was the standards version at the time. But Doug Crockford convinced me that there was a beautiful object capability language buried in JavaScript struggling to get out. So at that point, I joined the ECMAScript committee, the committee that standardizes JavaScript, alongside Doug Crockford, who was on the committee. And I've worked since then at getting the enablers into JavaScript for using JavaScript as a secure object capability language, and still with the focus on enabling JavaScript to be a good language for writing smart contracts. In 2013, the same year that Ethereum was born, I co-authored a paper with Tom Van Cutsem and Bill Tella. Bill Tella, the economist, who's also now a co-founder of Agoric. That paper was distributed electronic rights in JavaScript. I was still a researcher at Google, did not at that time anticipate leaving to form a startup, but I was explaining at that time why JavaScript was now a suitable language for smart contracting, giving good examples in the paper, and explaining how re-engineering JavaScript to that goal was actually making JavaScript a better general purpose language as well. So I've stayed on mission the whole time. And then in 2017, I think, 2018, I left Google to found Agoric together with Dean and Bill and Brian Warner, and to really capitalize on the fact that we had made JavaScript into that platform, and also gotten the seeds into JavaScript of becoming a secure distributed language, not just a secure language, which we're also now realizing at Agoric.
Yeah, fascinating. And I have had the pleasure of drinking quite a lot of wine with Dean Tribble actually in London at one point. So he is the one person from Agoric that I have had the pleasure of spending some time with. So let's get into smart contracts then. So you've already made this linkage, this kind of central mission at Agoric generally over this, these few decades, and of course how central JavaScript is to that mission. So as I understand it, we can look at what you're doing at Agoric in the context of smart contracts, because so today, and if you look at the website, you articulate these 2 points really well. So today, smart contracts in the context of, say, Ethereum are hard. I mean, you could say that generally, I guess, and they are insecure. So could we talk about those two areas of how you would critique smart contracts as implemented on blockchains today, and then we can get into how Agoric creates a better version, a better standard, I guess, for smart contracting.
Yeah, so part of what drove me into seeing an opportunity in leaving Google and starting Agoric was we were seeing these bugs happening in smart contracts on Ethereum, bugs including on contracts that had been carefully constructed by experts who put a tremendous amount of effort into simple contracts. And nevertheless, bugs in those contracts would cause hundreds of millions of dollars to disappear overnight with no recourse. And the whole e-community, everybody who had participated through the late 90s or early 2000s in the e-open source community and the exploration we were doing about how to do smart contracts in terms of our abstractions, was looking at that and saying, my God, if they had just been writing the smart contracts the way we were writing them back in the early 2000s, they wouldn't have had these bugs. A lot of these bugs would not have been possible. Obviously, some of them would have. It doesn't solve all bugs, but a tremendous number of these bugs just wouldn't have been possible. So there's basically two opposite approaches that you can take towards the central problem of computer security, which is access control, which is the issue of what actions are allowed in what context. And those two approaches are identity-based access control and authorization-based access control. So let's start with identity-based access control. Most of our operating systems, all the operating systems that are in widespread use are based on identity-based access control, where all questions start with who is making the request, who is asking, and then depending on the identity of the requesting entity, the action is then allowed or not. So this shows up in Ethereum with the fact that anyone or anything can send a message into any contract. So a contract, when it receives a message, knows that the message might have come from anywhere, and therefore it might be meaningless or malicious. So in order to figure out how to react to the message, the Ethereum contract has to do some kind of check. And the mechanism built into Ethereum that all of Ethereum contract security rests on is an identity check. There are two. The one in widespread use is message.sender. And that basically says, depending on that identifies in an unforgeable manner the identity of the requesting entity, and then based on that, a separate access check is performed. So the comparison I like to make is, let's say that my car did an identity check on me before it let me drive it. In that case, when I want to ask you to, let's say, do me a favor, drive my car to the shop, I would have to tell my car about your identity, make sure my car knows that you're now authorized to drive it. You walk up to the car and you drive it, but now you find that in order that is part of what you're doing, you need to hand the car over to a valet. Well, you're not the owner of the car. You can't ask the car to authorize the valet, so you're stuck. So there's a whole lot of composition problems that you get into with identity-based access control. With authorization-based access control, the core concept is the bearer right. And going back to the same analogy, that's the car key. I want you to to do a favor for me, to drive my car somewhere. I hand you my car key. I didn't have to tell my car that you're now the authorized driver. I just communicate the car key to you. When you now need a valet to park it for a while, you can hand the car key to the valet. And so the first thing is it enables composition. So it enables smooth compositional subcontracting relationships where I make requests of you and I give you the access that you need to carry out that request. The other thing is it enables narrow delegation. I didn't give you the ability to do a full impersonation of my full identity. I enabled you to drive my car. I did not enable you to empty my bank account. So this is what we call the principle of least authority. So object capabilities, these bearer rights, give you narrow delegable authority. And then this is directly what object programmers are used to with the object reference and the message pass. When one object makes a request of another, it includes in the message as arguments references to other objects. And that communicates not just what the object the request is about, but it communicates access to the object. So the receiver of the message now has access to the object that was described. So all this together creates a very, very abstract and compositional system of secure computation that composes together with the richness we're used to from objects. A lot of the richness of the modern world that we have is due to the compositional nature of object programming. The fact that objects can delegate to each other in this local manner without needing global information. The fact that the requests they make to each other are abstract requests. All of this works well to create these very, very rich compositions. Ethereum contracts, for all that people talk about DeFi logos and talk about composition, the kind of composition they're actually experiencing on Ethereum and the limits of composition you can experience on Ethereum is very, very shallow and narrow compared to what object programmers are used to and compared to what we're now used to at Agoric. Okay. On top of that object level, we build a financial level, and we build a system of tradable electronic rights to start with what we call ERTP, the Electronic Rights Transfer Protocol. The Electronic Rights Transfer Protocol gives you one set of encompassing encompassing abstractions, that within that umbrella abstraction, we've got fungible and non-fungible rights, rights that are perishable and non-perishable, symbolic and exercisable. There's a whole wide range of variations and kinds of rights, such that that whole range of variation can all fit within the ERTP abstract set of interfaces. And what's important about that is that we found that we can now write and have written a wide range of contracts and contract components, various kinds of derivatives, covered calls, financialized call spread options, auctions, automated market makers, a whole bunch of different institutions, many of which can deal with any right that can be described in ERTP, but some of the rights that plug in have to be particular kinds of rights. So, for example, Uniswap, or our version which we call AutoSwap, that has to do arithmetic on the quantity, so that requires a fungible right in that for that part. But most of the components of most of our contracts can deal with any kind of right. And now the place where we get into the kind of higher order composition that modern software engineering is based on and that gives rise to the richness of modern software is that when you have a contract that unfolds over time, the right to participate in that contract is itself valuable. So what we've been able to do in our framework is we take that right to join a contract, we call that an invitation. The invitation is itself a kind of asset that fits within the e-right umbrella. And now any of our generic contract components that you might have been able to feed some tokens into, or you might have been able to feed non-fungible tokens into, or various different kinds of things, you can also now feed invitations to participate in contracts into. So without those components themselves being different. So now the kinds of rights that these contracts manipulate are also the kinds of rights that these contracts create. Simply by virtue of being a contract that it's valuable to be a participant in.
Yeah, and of course, then on top of that, you have the fact that JavaScript is already used by millions of people, so it's more accessible to a wider pool of existing developers rather than Solidity, which is introducing a new order of complexity. So if we say this maybe original version, slightly evolved, but original version of smart contracting sits alongside, let's call it a pretender, or challenger, which is the instance in Ethereum. I don't mean to make it so polarizing, but just to play out the scenario. Ethereum has attracted mindshare and a degree of economic activity, and of course, it has a token that presumably forms some kind of moat to keep economic value locked into the system. People have an economic stake in that system and its success. How does Agoric and what it enables play out alongside that? Is the argument that it doesn't need to compete with that because that's still too small a percentage of the global developer population? Or, how does that play out as two opposing systems?
So in terms of installed base as an attractor, which is a major issue in entering into a market, Ethereum is certainly an installed base that has a certain gravity to it, a certain attractive force for bringing more activity into Ethereum, because that's where the activity is happening. For opening things up to the mainstream, of course, JavaScript is, of course, also a tremendous installed base along a very different dimension. So we're being able to benefit from that one, whereas Ethereum is pretty much locked out of the second one, but that still doesn't answer the first question, which is, what do we do about at the level of financial assets, at the level of the existing volume of smart contracts? Ethereum's installed base. We have a very nice way to approach that, which is Ethereum is one of these blockchains that the first wave of blockchains, including Ethereum, I characterize as each blockchain was built as if it is supposed to be the only blockchain in the world. So Ethereum doesn't have, as part of its conception, that there is a world of smart contracting outside of Ethereum. The world of smart contracting that our community had been about through the 2000s, well before the invention of blockchain, was always one that was more like the web, but decentralized in the sense of separate platforms that are only loosely coordinated with each other, that have to agree on protocols, but are not built to trust each other. They're built to be mutually suspicious, but nevertheless interact with each other. So the first major blockchain project to take this approach, to really view itself as enabling a federation among blockchains, of coexisting with many other blockchains, was Cosmos. I would also say that Polkadot is in large measure thinking in terms of federation. And the Agoric technology is platform neutral. It's able to run on a number of different blockchains. It's built to be able to run on a number of different blockchains, both public and private. It's also built to be able to run on non-blockchains. It's built, the main thing is it's leveraging the distributed secure computing nature to be able to interoperate between mutually suspicious platforms, where any of those platforms might be an individual machine, might be a server inside a company, might be a public blockchain. To us, a public blockchain is just a highly credible computer that's built out of multi-way agreement rather than being built directly out of silicon, but it's still just one node on a network. So we've been working with Cosmos and the Interchain Foundation. Agoric has been collaborating with them on creating the IBC protocol, the inter-blockchain protocol. And our distributed secure object protocol, CAPTP, capability transfer protocol, rides on top of IBC. And then at our financial level, what we've built on top of ERTP is we built the two most important things we built on top of ERTP is, on the one hand, Zoe, which I'll get back to, which creates a framework for writing smart contracts with some really important novel safety and simplicity properties. And on the other hand, Pegasus. And Pegasus is key to this issue of Ethereum as an attractor. Pegasus and the aligned Peggy project at Cosmos are what they're about is creating local assets that are peg mirrors of remote assets. So by having a remote asset, so I'll give the example of right now you can use Pegasus on the Agoric blockchain to peg Cosmos atoms where the atoms are on some other blockchain without the two blockchains trusting each other. And there's three levels of protocol that are relevant here. There's the IBC level, which is the communication blockchain to blockchain, so that a contract can get reliable information about what happened on another blockchain. There's the CAPTP level that turns that into secure messaging between objects running on those different blockchains. And then there's the ERTP and Pegasus level that enables us to create an ERTP surface, an ERTP window into assets whose native representation is not in ERTP. So you can basically lock those assets up in their native location, turn the locked assets into an ERTP wrapper within our abstractions, get all the benefits of the ERTP trading with regard to those assets, and then later cash them in to unlock the original assets. Our plan is to do something very much like that for Ether, for ERC20, for Bitcoin, and the result is that the Agoric platform no longer has a severe penalty for not being where the assets are that people want to trade. That, okay, the assets are over there, but you don't have to go there to trade them. You can go here to trade them because we've gotten rid of all of the friction that makes you need to go there. So I don't have to travel to New York in order to buy and sell stocks on the New York Stock Exchange. There's plenty of lubrication in the system that have reduced those frictions so that you can trade anything from anywhere in the world. Likewise, in order to follow a link into a particular website, I don't have to be on the website. The whole World Wide Web is all about links being this frictionless way to go from a page on one website to a page on another website. So by removing those frictions, you remove the specialness of the attractor. And now the issue of where do you want to write the contracts, the attractor is now no longer where are the assets, it's what is the best platform for writing a contract. And we've built a much better platform for writing the contracts. And then that will in turn attract assets into our platform. But the location of the assets at any moment is not what causes the system to be sticky.
Got you. I mean, that was a fantastic explanation. If I was able to follow it, I'm sure everyone else will. So let's zoom out, because again, I want to make the most of having you on here. I know smart contracts to you are important at a societal level. Yes, this is a startup, but it's not just a commercial endeavor. There is a purpose, as you say, behind your devotion to this mission across your career. So let's zoom out. If we solve for this, both at Agoric and, as you say, collaborations with IBC and whomever else, what's possible? What do we solve for? Give us an optimistic view on the world.
So I'm very glad you asked, because certainly the reason why I've stayed on mission on this for decades is not because I thought I could, not simply because I thought, well, I can form a startup and get some good return on investment. That this was a mission worth decades of my life because of the effects I'm hoping it has on human society, some of which I think it's already had. And the phrase that I think covers much of what I've done throughout my entire professional life is, if you can lower the risk of cooperation, you get a more cooperative world. So we're very used to people talking about the benefits of rule of law. Well, what do we mean by rule of law? What we mean is that there's a understandable, unambiguous system of rules that apply reliably, neutrally, and uncorruptibly, such that within that framework of rules, gives people an opportunity to interact with each other cooperatively, but the same framework of rules gives them an architecture in which they can arrange to try to realize cooperative opportunities while still protecting while each is still protected from the potential misbehavior of the other, where you can reduce your risk from the possibility of the other party misbehaving. So this comes up at many, many levels, but contracting is kind of the ultimate level of that, because contracting uses the rules of the framework to design a set of rules that characterize the contract itself. So each contract is a custom set of rules that's embedded within this enabling framework of rules. And the contract, when you think about my favorite metaphor for what a contract is it's like a board game, that the contract is like the rules for a board game. So when we negotiate a contract, what we're doing is we're designing the rule, we're trying to find the rules of a board game that we would both be willing to play. Because commerce is positive sum, we'd both be willing to play it because we both expect to win. And within the positive sum world, both of us winning is not a contradiction. It's what's expected, it's what typically happens. So we construct these rules for us to have this cooperative interaction. And one of the things we have in mind is, in those rules, is that the other player has different interests and might act in a way that we don't expect. We're each trying to protect ourselves as well. And then what we want is, once we've arrived at those rules, we want to now interact according to the rules of that game in an uncorruptible manner. And what that means is that we're each bound by those rules. Now, before smart contracting, before being able to write the code of the board manager as a program that runs on a computer, in the current world of centralized finance, by which I just mean the real world finance as we've experienced before blockchain, in that world, the enforceability of the contract depends only on the incorruptibility of human institutions, and depends on dispute resolution processes where if somebody violates a contract, we take them to court. And the problem is, A, human institutions are not incorruptible. They can have very high reputations. They can have operated for a very long time at a high reputation. But then in an emergency where things really matter and the existence of the institutions are threatened, people can act in a panicky manner. And even with a very long history of operating a high reputation, that's no guarantee of continued incorruptibility in an emergency where it matters most. But the more important thing is that there's a cost threshold. The enforceability of contracts matters if the values at stake are adequate to be worth taking somebody to court over, and if the contracting parties have the resources needed to take them to court. Those are tremendous costs, and that means that the utility, the benefits of rule of law actually only start at a very, very high cost threshold. So one estimate that I think is conservative says that of all the people in the world, 4 billion of the people in the world do not get to operate with the benefits of rule of law. Now, by creating a computationally based way of expressing the contracts to where the meaning of the contracts is much less ambiguous, is subject to formal analysis, is subject to testing, it's subject to stress testing, so you can see what the contract does in an emergency and get some actual information about the emergency, whereas you can't test what people would do in a panic. The computational embodiment gives you a reliability of what the contract means. Blockchain is a fundamental innovation, which is one that I did not see coming in all of my years of smart contracting before blockchain. Blockchain was a brilliant innovation because you've got the ability to build the computer out of agreement, out of massive multi-way cross-checked agreement, enables us to build what is essentially a virtual institution. Each blockchain can be thought of as a virtual institution that is much less corruptible. It's not incorruptible. There's never zero risk, but it's much less corruptible than anything human beings have ever been able to produce by any institutional arrangement in the past. And it's a huge leap forward in the incorruptibility of the institution. It's not only incorruptible by the people participating in the institution, it's incorruptible by the governments of the jurisdictions of the people participating in the institution. So one of the big ways in which the world, as we're experiencing it, does not fit with the institutions that the history of the world has evolved to up till now, is that commerce and contracting, and in general, our cooperative arrangements with each other, are mostly free of geography, have nothing to do with the geographic location. For many of the people that I deal with on the net, whether it's by email or by contracting, whatever, I don't know where they are. I don't need to know where they are. They're reachable over the net. But all of our frameworks of law that we generally mean when we talk about rule of law are all jurisdiction-based, which is largely geography-based, and they just don't fit. So between the corruptibility of governments, the huge costs of making use of the rule of law mechanisms, and the fact that the mechanisms have gotten very complicated and non-neutral. There's all sorts of special case carve-outs, each of which is a form of corruption. So anytime the law gets too complicated to understand because it's responded to lobbying by particular parties to make particular special cases, that's a corruption of the rule of law. That's no longer what we mean when we say the rule of law. So in all of these ways, this idea of rule of law that we've come to prize so much, that was part of the ideal that we wanted to shape governments to provide, governments are not close to that ideal. And we now see for the first time an ability to build something that's much closer to that ideal. And the result is that we can build a world that's much, much more cooperative, that's much more open, that opens the benefits of rule of law to many different levels of wealth. No longer starts only where the benefits no longer start only at some very high value. So we can all now cooperate with each other in a much less risky manner and a much more reliable manner.
Wow, Mark. I mean, I've been in the space that I would call Web3, blockchain generally, for over 7.5 years. This has been the most inspirational conversation I've had in all that time. It's been a huge pleasure. I know that the audience are going to feel the same way that I do about this. I had a few goosebump moments hearing you talk about that, because to be honest with you, even though I've been in it for 7.5 years, you can't help but sometimes think you're just drinking the Kool-Aid. And so to have somebody like you that's been so instrumental in the history of the internet say blockchains are really important, one of the most important innovations humankind's ever created, makes me feel somewhat comfortable that I might be in the right space. So I just want to say a big thank you to you. You're definitely an inspiration to me, I'm sure, to founders coming into the space and developers generally. So thanks for everything that you're doing. Hopefully I get to meet you in person before COVID, subsides. I look forward to that day. So stay safe.
Yeah, thank you. It's been a real pleasure.
If you enjoyed today's podcast, please make sure you subscribe, rate, and share your feedback to help us reach as many people as possible with the important mission of Web3.